My name is Jared Gibbs. Today I'll be sharing my research on artificial sweeteners and their proposed ability to help somebody on a diet manage their weight and appetite. The claim that these products make is that you can have soda and not consume additional calories. You don't have to give up soda for your diet. However, there's room for skepticism. We've all been behind the big guy at a restaurant counter that orders biggie-sized meals and a Diet Coke to wash it all down. These sweeteners clearly aren't doing this individual any favors. There's claims that these sweeteners have adverse effects, such as increasing one's appetite and making it harder to control cravings. My research aims to address these concerns. When searching for resources, one thing that works well for me is what I call subject head surfing. I go to EBSCO and type in some keywords and filter the results down by date. I usually just go with journal articles, but sometimes I'll include newspapers and magazines if I need a source to explain a concept. From there, I'll click on articles that are close to what I'm looking for. The subject headings are often other keywords or synonyms that I hadn't thought of before. Browsing from those and adding them to my keyword collection has proven very useful. Another tool that I use is Google Scholar. The search algorithm is so much better. I can often find full-text articles with either the Find It at ISU link or by copying the title and pasting it into one search. YouTube may be an up-and-coming resource. I type in authors on articles that I've found, and I found an excellent TED Talk presented by a scientist from an article that I had found who was able to summarize and apply some of the findings. All right, now on to the research. These sweeteners work by triggering sweet receptors on the tongue. Our bodies can't metabolize the sugars, so we don't get any energy from them. I want to share two experiments that suggest the effectiveness of these sweeteners. The first experiment is trying to gauge appetite control after consuming various sweeteners. Subjects were given a snack before lunch and dinner. This snack is sweetened with either stevia, aspartame, or sucrose, which is regular sugar that you'd find in your pantry. They are then allowed to eat whatever and however much they'd like for lunch or dinner. The regular sugar group serves as a control. We assume that the subjects served a snack sweetened with regular sugar will demonstrate typical appetite characteristics. The study found that those consuming stevia and aspartame actually ate less and felt fuller for longer. There are some things to take into consideration with this experiment. This study isn't designed to monitor long-term effects of consuming synthetic sugars. It only fits in the scope of one day. Another issue is that there may be social pressures and fear of judgment affecting the results. I know if I was being evaluated on my appetite, I would probably eat less. The next study tries to answer the question of how diet sodas impact one's ability to lose weight over time. 303 subjects were involved in this test. They were all part of the same diet and exercise program. They were split into two groups. One group had to drink 24 ounces of diet drinks each day. The other group was not allowed to drink diet sodas and was required to drink 24 ounces of water each day. They could drink whatever they wanted aside from those restrictions. The results look promising. The diet soda group lost more weight and more weight quickly. This graph was a little tricky to interpret. The y-axis is percent in weight change, not actual weight itself. All data points lie in the negative region, meaning a negative percent change in body weight. You can see that the function reascends, but that doesn't mean that they gained weight. It just means that the rate that they lost the weight decreased. There's many issues with this study, though. Of the 303 beginning subjects, only 222 remained at the end of the year. It's a major problem with those subjects who are not included in these results. We'll never know why they quit, but it's safe to say that nobody sticks to a weight loss program that doesn't work. For extra incentive, the drinks were paid for, and each member was paid $90 every 3 months, so it wasn't likely a financial hardship. Another possible problem is that it is disclosed in the article that some of the scientists were receiving consulting fees from Coca-Cola. Even though it's disclosed, I still find it a little suspicious. The biggest concern I have is the people behind the study. Unfortunately, we live in a time where highly educated people can abuse their titles to rip people off. It's easier to sell books and pills online to vulnerable, gullible people, and it probably makes more money than it is to work in a lab, clinic, emergency room, or other PhD, MD, doctory kind of a place. That's why it's so important to research people. A big red flag to look out for is if they sell supposedly scientific stuff like books, pills, or medical devices, based on claims that haven't gone through the peer review process. These scientists then band-aid this by getting other doctors and scientists that also don't want to do doctory stuff anymore to sign off on it and make it seem credible. At least 3 of these authors of this experiment write books with typical high-promising titles like you'd see at a magazine stand at the grocery store. There's nothing wrong with making a little money on textbooks. That's just making a living from teaching. These books, however, are clearly targeted to vulnerable people in need of easy answers. It's also not particularly inspiring that between the 3 of them, they can't spell intelligent, as can be seen on the front cover of one of Dr. Hill's ebooks. My next lead took me down the path of studying the gut microbiome. I found an ebook on Clinical Key entitled Nutrition, Malnutrition, and Probiotics that describes in detail what the gut microbiome is and what the function of various bacterial species is. Our bodies have around 10 trillion cells. The population of bacterial cells in our microbiome is 10 times that, and between around 300 different species. What we eat affects them. What nutrients they do or do not get manipulates their populations and diversity, which in turn affects us. This is Aaron Segal, an author on a paper that documents an experiment carried out on rats and mice that were given artificial sweeteners. The gut microbiome was altered in mice given artificial sweeteners, and some showed signs of diabetes. They were then given antibiotics to clear out the microbiome, and a new one was transplanted in from normal mice. Their blood glucose and insulin levels normalized. In this video, Segal talks about a study where they were able to track glucose levels for their subjects in real time. 1,000 participants wore a glucose sensor for a week and logged what they ate with an app. He found that people react differently when they eat the same meal, while an individual's response is fairly predictable. For example, here are 2 diets from his study. They don't look particularly diety, do they? Yes, at the bottom on the left there, that's chocolate, and on the right, that's ice cream. What they found is that some subjects' glucose levels remained consistent with one diet, but another subject's glucose levels were more erratic. His findings demonstrate that there is no perfect diet. We are all different and process food differently. He claims to have found correlations between gut bacteria, age, gender, and other characteristics. He then takes this information and designs an ideal diet for each individual. It sounds promising, and for $300 and a willingness to FedEx some of your poop, you can try it for yourself. Although the studies and documentation provided seem to support his ideas, I can't help but feel skeptical when scientists monetize their findings. I have to wonder, has the research hit a wall and they are just trying to cash out before the word is out, or are they just plain greedy? I don't know. Only time will tell. The research in this area seems to be in its infancy. The mice study that Segal references was published just barely 2 years ago, and the presentation that he gave for his most recent study was given just last July. Given the number of bacterial species, the byproducts they produce, and how they interact with the many chemical systems in our bodies, it's not unreasonable to think it will take much more time to gain an understanding of these processes.